Hello and welcome to today's video. In this video, I'm going to go over 4 practice problems and we're going to focus on conditions and branches. To watch this video, you need to know conditions and branches, and you better know about debugging. I'll put the link to those videos in the description below. As always, I'm going to put the timeline of each question in the description. So if you wanted to jump between the question or skip one, you can easily just click on the question you wanted to focus on the description, and you'll get to that timeline. First problem is that suppose that a particular steel mill, steel bars are grouped into classes according to their yield strengths, as shown in the following table, as you can see in the screen. Note that this is not a standard classification, it's just here for practice. And if you look at the table, you would see that if strength is bigger than 1000 MPa, which is short for megapascal, we would consider it as class A. And if it's between 1000 and 800, we will consider it as class B and go on into class E, which is strength less than 400 MPa. The problem is asking us to write a code that reads the yield strengths of the steel from the input and then writes the output to the screen, as you can see on the screen. So the output should look like this. You print the message, enter the yield strengths MPa, and the user will input 649.4, and your program will output still having yield strengths of 649.4 MPa is class C. Let's jump to Visual Studio and see how we can solve this problem.
Okay, here's my Visual Studio. I've started by just include stdio.h and the main function and return 0. So now I'm going to populate it with the code. As always, I'm going to divide it into different tasks. Step 1 is to declare our variables. Step 2 is to ask the user to enter the yield strengths in MPa and scan that. Step 3 is to decide on the class. And step 4 is to print the output on the screen. Guys, I should tell you something, that the way I do this question is not the only way you can do it. These are simple problems that can be done in alternative methods. So if you're doing something that takes the same input and produces the same output as provided in the question, feel free to use that one, and that is correct. Okay, so to declare my variables in this question based on what is asking from me, I know that I need a float number to store the strengths, and I need to have a character to store the class of the class. In this case, character could be A, B, C, D, or E. And of course, I can go ahead and write a program without any character variable. I just need to combine step 3 and 4 and write my printf statement inside the if condition. Okay, so step 2 is, we have done it a lot of times. You ask the user to enter something and then scan it using the scanf function. Should be easy. Step 3 here is the important part. So step 3 is asking us to write an if-else statement. So help us to identify the class of the steel. Let me copy what was provided in the question here so it can help us better write this. Okay, so as you can see on the table, class A is for the strengths bigger or equal to 1000, and it goes on every 200 MPAs. So if I read this in plain English, I would say if strength is bigger or equal to 1000, it is class A. And it's actually, the programming is exactly the same way. I'm just going to write this. So if, and my condition, which the condition when we read it in English, we said if strength is greater or equal to 1000, and then the body of the what will happen if strength is bigger than or equal to 1000. What would happen at that point? At that point, So I'm gonna write it as a comment. So the class would be A. And if we continue reading it, if it's between 800 and 1000, it's class B. So one thing we should notice here, so we want this condition to happen if this one is not true, if it's false. If it is false, it means that we already know a strength is not bigger than equal to 1000. A strength is less than 1000. So if you look at condition for class B, it says it has to be less than 1000 and bigger or equal to 800. So this part, if the first if statement is true, this part is already checked. If I am in this else if statement here, it means that this part is already satisfied. I only need to check this part, which is the strength is bigger than equal to 800. So I'm going to write it. Strengths bigger or equal to 800. Okay. So at this point, I know that when I'm here at the body of this code, strength is less than 1000 and bigger than 800, then I can decide that the class is B. Okay. And then continue on for class C, D, and E. And when I checked everything for class E, it's just else. You don't need a condition for the last one, because if it's not less than if it's not bigger than 1000 or 800 or 600 or 400, else any other way, it will be class E. So if you continue the code, the last part, if you write all the if statements, the last part would be just an else statement, and the class would be class E. Okay, that's my hint for question 1. Try to do it yourself and let us know if you need any help.
For the second question, the Fujita tornado scale categorizes tornadoes according to their peak speed. The categories are as follows: F0 when the wind speed is 72 and less, F1 when the wind speed is 73, F1 when the wind speed is greater than 73 and less than 112. And as you can see on the screen, this list goes on until category F6. So our job is to write a program that reads a peak wind speed in mile per hour from the keyboard and writes the tornado category to the screen. For instance, if I run my program, the program would enter a peak wind speed mile per hour. And if I input 256, the output should look like peak wind speed equals to 256 mile per hour, comma, tornado category equals F4. So let's jump to Visual Studio and see how to solve this problem.
So question 2 is similar to what we did in question 1. As you can see, I wrote these steps. It's similar to what we wrote for question 1. We just declare the variables, prompt the user to enter the wind speed, and then we scan that wind speed, and then we checked it against what we provided in the table. Let me copy the table here so help us write the if-else statement easier. I'm going to put it as comment here. Okay, so if the category, if it's the wind speed is 72 or less, if it's category F0. But one thing to be careful here, you might say that we haven't talked about the strings yet, and F0 is a string. You are correct, but if you look at all these categories, F is something constant. And we don't need to be worried about the character F. It's just the category 0 to 6 that we need to be worried about. So if I had an integer and I name it cat for category, and then in step 3, the first thing we need to do is to check to see if the wind speed is less than 72 or not. So if exactly how we read it in English. So wind speed less than or equal to 72. And then in that case, cat would be 0. And in my printf statement, I can come here and just put f percent, uppercase F, %d, and instead of %d, I'm going to put the category. So automatically it will print category 0, F0, F1, F2, F3, whatever the case is. But let me go back to step 3. When we check this wind speed against 72, now the second step is to see if wind speed is between 73 to 112. Forget about this if statement and write another if statement and check if wind speed is greater or equal to 73 and wind speed less than or equal to 112. And then I can go ahead here and say it's category 1. But there is a problem here. I'm writing this part of the code, so when you go and actually run your code, you would see both if statements are going to be executed. So the code will be a line 11. If it wasn't true, if, for example, user input 75, this condition would be false and we will be jumped to line 16. When we are at line 16, first this statement will be checked, then this statement will be checked. If both statements were true, then we will be jumped into the body of the if-else statement and the category would be 1. So what I'm doing here, I have an extra check here, because if I already checked and I know when the speed is bigger than 72, so an integer bigger than 72 is 73 or above, then this check is redundant. We don't need it. If I remove this and puts it in the previous if-else statement that we have, so only time this situation, this condition will be checked is that if wind speed was not less than or equal to 72. So if wind speed is not less than or equal to 72, definitely wind speed is 73 and above. And I'm going to check it against 112 and then go ahead this way. So although I'm not checking both, but I'm considering this 73 between 73 to 112. If it was in a standalone if statement, like what we did before, you need to put both conditions, and both conditions has to be true, so it would be category 1. So the next step is step 4 to print the output on the screen, as I give you a brief example, and you should be able to fill the rest and let us know if you need any help.
Certain cities have very smoggy condition. 3 components of the smog are ozone, nitrogen dioxide, and carbon monoxide, are a particular health concern. A pollutant hazard index has been developed for each of the 3 primary irritants. If all indicates are less than or equal to 100, the smog level listed as low is forecast. If any raises above 100, the smog level is listed as medium. If any index rises above 200, the smog level is listed as first stage alert. If any index exceeds 275, the smog level is listed as a second stage alert. Write a program that reads in the daily hazard index for each deterrent pollutant and that identifies the smog level of the air as low, medium, first stage, or second stage alert. For example, if the user enters for the ozone 154.2, 210.5 for nitrogen dioxide, and 98.6 for carbon monoxide, your program should output the smog level is first stage alert. Let's jump to Visual Studio and see how we can save the cities.
So in this question, we also have three different steps. Declare our variable, prompt the user to enter the indices and read the indices, scan the indices. And step 3 is to decide on the smog level and print the output to the screen. So if you look at the question, we have three different indices. So I'm going to use float and define one by one. The first index is ozone. The second one is nitrogen dioxide. And the third one is carbon monoxide. In step 2, I'm going to print a message to the user to prompt the user to enter the first index. So the message would be enter the ozone level. I'm going to scan it using scanf function, and the formatted argument would be a float number, and the float number would be stored on the memory address of ozone. And I'm going to repeat that for nitrogen dioxide and carbon monoxide. Now let's put a breaking point at line 18 and debug our code to see if our code is working perfect and we can read ozone, nitrogen dioxide, and carbon monoxide. If I go to the debug menu, click on start debugging, okay, we would be transferred to this debug window. It's asking us to enter the ozone level. I would input the ozone level as 154.2, and then the next is nitrogen dioxide level, which is 210.5, and then next one is the carbon monoxide level, which I will put 98.6. If I hit enter, we're going back to the debug window. As you can see in the local window, we have three different variables. All of them are initialized with the numbers we just input on the input screen. So it means that our code is working up to this point. Let me stop debugging. So now I'm going to decide what is the smog level. If you look at the question, I'm just going to copy the text in the question here for you guys so we can check the level, check the levels easier. I'm going to bring it as comment. So the first statement says, if all indices are less than or equal to 100, the smog level listed as low in forecasts. The next if statement, I'm going to bring all here. So if I read all four of them, the first one is, if all indices are less than or equal to 100, the smog level listed as low in forecast. If any index rises above 100, the smog level is listed as medium. If any index rises above 200, the smog level is listed as first stage alert. If any index exceeds 275, the smog level is listed as second stage alert. Okay, so the first condition is asking if all indices are less than or equal to 100. So it's the same as saying if ozone index plus nitrogen dioxide index plus carbon monoxide index are less than 100. So I can change the wording to this. If ozone is less than or equal to 100 and nitrogen dioxide is less than or equal to 100 and carbon monoxide is less than or equal to 100, then the smog level listed as low in forecasts. Okay, now I'm going to use a mathematical presentation. So this reads the same as what we had in plain English. I want to translate this into C. So after if, first of all, if has to start with lowercase I, Then it's the condition. Let me bring them all to one line so it's closer to C this way. Okay, so now I can change this and to its equivalent in the C language, which is 2 %. And now it is actually in the C language. If ozone is less than 100, and nitrogen dioxide is less than 100, and carbon monoxide is less than 100, less than or equal to 100, then if that condition was true, what I want to happen is I want the code to print that the smog level is low. This part is a code. It can be compiled by the C language. And if I bring it out of the comment zone, this is a perfect code and can be compiled by the C compiler. And I'm going to get rid of this comment here. So successfully translate the first if statement in the question from English to C. Now let's do this for the rest. So this one says if any index raise above 100, the smog level is listed as medium. I know that this condition, if any of them, if ozone or nitrogen dioxide or carbon monoxide, if any of them raises above 100, this condition will be false, and the instruction pointer will jump from line 19 to the next else if statement. So you need to be careful here that what is the criteria for it being medium? If I know that at least one of these guys are more than 100, then I need to check them all against 200. If all of them are less than 200, it means that the smog level is medium. So I know that at least one is more than 100 and the rest are less than 200. So the smog level is medium. So as I said, if ozone, for example, is more than 100, instruction pointer from line 19 will be jumped to line 23. And because the rest is less than 200, it will print the smog level is medium for me. Okay, let's go ahead and put the body of this if statement here. Okay, so the smog level is medium. Now I'm going to check against 275. Okay, let's go over the situation again. If one of these three indices, at least one of them, gets more than 200, it means that this condition is false, so we jump into line 23. Then this condition is also false, then we jump into line 27. In line 27, for example, imagine all of them are less than 100 except ozone. Ozone is 225. So this one would be correct because the other two is less than 100 and ozone is 225, which is less than 275. And that's exactly the criteria for the first stage alert. So that's the point. I'm going to put the next printf statement, and this printf statement is the smog level is first stage alert. Okay, the next part is the second stage, but look at it. If line 27, the condition at line 27 is false, what does it mean? It means that at least one of the indices are more than 275. Do I need to check it against anything? No. Any condition, if the first, second, and third condition is not true, is false, it means that we are at the second stage alert. So this time I'm going to just put else. And then my printf statement, which says the smog level is second stage alert. Okay. Debugging is going to help a lot. Let me get rid of these comments here. Would help us a lot. Okay, I'm going to put a breaking point at line 19 and debug this carefully to see what is going to happen.
I'm going to press F5. Okay, now we are at the debug window. Let me actually bring this a little bit lower so we can see our if statement full. So what I'm going to enter is, let's put 3 numbers that are less than 100. So 90 for ozone, 90 for nitrogen dioxide, and 90 for monoxide. And if I press enter, so let me actually bring this up first to check if all, okay, as we saw earlier, this is working the way I want it to work. So all 3 were being scanned correctly. But right now we're at line 19. If I step over this line, what's going to happen? If this condition is true, I'm going to jump at this line. If the condition is false, I'm going to jump at line 23. This yellow arrow is our friend here. If I step over, we're at line 21. It means that this condition was true, and that's exactly what we want. It means that we wrote the code the way we wanted, and we're good to continue. And if I step over, this being printed. The good thing with else and if statement here is if I step over, none of these codes, guys, will run. We will jump right to the return 0 statement here. So if I step over, we're at return 0 and the code is done. Let's restart debugging. Now I'm going to input, let me screw this up a little bit. Okay, now I'm going to input 110 for ozone, 90 for nitrogen dioxide, and 80 for carbon monoxide. If I press enter, now I'm at line 19. Of course, when the yellow pointer is at line 19, means line 19 has not been executed yet. If I step over, we're at line 23. It means that this condition was not correct. And that's true because ozone is greater than 100. It's 110. Now all the indices are checked against 200. And this condition, the condition at line 23, true. I'm guessing it's true. I want it to be true. So I want my instruction pointer to jump to line 25 after I press a step over. If I click on a step over bottom here, you would see that the smog level is medium. So we are at this line. Obviously, this line hasn't been executed. I have to step over it. And then you would see that the smog level is medium is being printed to the screen. And if I step over, we're going to return 0. Let's try another one. Restart debugging. This time I'm going to enter 275 for the ozone, 300 for the nitrogen, and 100 for the carbon monoxide level. And if I press enter, again, we're at line 19. I expect that this condition is wrong. And if you read it, you would understand that this condition is wrong. This is also wrong. And this is also wrong because carbon monoxide is more than 300. So I expect the output should be the smog level is the second stage alert. But let's see what is happening. So first, line 19. If the condition is false, we'll go to line 23. That's exactly what happens. If the condition is false, we're going to line 27. That's exactly what happens. If the condition is false again, we're going to the else statement. That's exactly it. So we won't stop at line 31 because there's no check, it's just else. And we'll jump to line 33 to print. The smog level is on the second stage, and then on the return 0, and then finish the program. So let's get out of debugging. So that's the code we wanted to write for this problem. And debugging is a great tool when you are facing if-else statements. Basically, when you branch your code, when you do loops using for loop, while loop, or you have if-else statement in your code. This way you can test your code. Testing your code, guys, is very important. You need to test your code with different variables, different inputs
to see if in any condition your code would work or not. And now my code is working here, and then I can go ahead and submit the solution.
That brings us to practice problem number 4. Practice problem number 4 is to write a program for hotels which computes the cost of a stay at a certain hotel that are different rate for high season versus low season and weekdays versus weekends. High season consists of months of June through September. Weekdays are Mondays through Thursday, and Friday, Saturday, and Sunday would be considered as weekends. The cost of a stay at the hotel is determined according to the following. At any stage beginning on the weekday during high season is charged at rate of $150 per night, even if part of the stay extends to the weekend or into low season. Any beginning of weekend during high season is charged at rate of $195 per night, even if part of stay extends beyond the weekend or into low season. Any of a stay during low season is charged at the rate of $99 per night, even if the stay extends to high season. So what the question is asking us to do is, our program should read the months and day of checking in and the duration of stay, then compute the hotel cost of the stay. For example, the input asked me to enter the check-in months and January for 1 through December 12. So I'll input 7, enter the check-in day, Monday 1 through Sunday 7, and I'll input 5, and enter duration in nights, and I'll input 3. And your program should calculate the cost of living and output. The cost of a stay is $585. Let's jump to Visual Studio and see how we can program this.
Okay, so for this one, I would also break the code into 4 different steps. Step 1 is declaring your variable. So for months, day, and duration, it's integer, and the cost would be a float number. Then you prompt the user and a scan. So I would prompt it one by one, then first prompt it for the check-in months, and then check-in day, and then the duration of the stay. So now I have all the input from the user. So on a step 2, 3 different printf statement and 3 different scan of a statement to scan the months, day, and duration. And then in a step 3, which is calculate the price, what I'm going to do is I'm going to use if statement inside if statement. So let me clear one thing, guys, here. There are a lot of ways you can do this problem. I would say 3 to 4 different if-else statements, top of my head, and probably it's going to be more than that. You can do this problem, so you don't have to do it the way I'm doing it. So what I'm going to do first, I'm going to check if the month. So first, I'm going to check for the high season. So for the high season, I'm going to check to see if months is greater than equal 6. And months also has to be less than or equal to 9. So what I'm doing here, let me actually point this out using comments. Check for high season first. And then inside this, I would put another if statement. In this if statement, I'm going to see if it's weekend or not. So how to do that? It's the weekend is either day 5 or day 6 or day 7. To write that and see it's day, I'm going to check, is day 5 or is day 6 or is day 7. So if any of these 3 statements are true, we'll go to the body of this if statement, which is nested if statement. Nested if statement is one if statement inside another if statement. Okay, then I'm going to calculate the cost. And cost would be, so the cost of staying on the high season and weekend would be 195 times the duration of stay. And then else would be high season and weekdays. And else here would be low season any day of the week. So so I have 3 different parts to calculate the cost of stay. And then when I calculate the cost, I'm just going to print the cost out to the screen using a printf statement here. You guys can do that easily. We have done practice on it a lot of times, but I'm going to repeat that, guys. This is not the only way you can write a step 3. There are many different ways you can write a step 3. Feel free to do your own and probably try to practice a couple of different ways to get more familiar with if else statement, because to be honest, programming is just practice and practice and practice. You can only become good in programming if you practice a lot.
Thank you guys for watching today's video. Please let us know if you have any questions or comments, and we'll see you on the next video.